Hi friends, welcome to follow up. Let's have a look at problem 287. Find the duplicate number. So in this video, we're going to explain several methods. So they are based on set, on using index as indicator, and using slow and fast pointers. So here, let's first look at the problem statement, because the problem is very special. Let's see where the speciality lies. So here we are given an array called nums containing n+1 integers, and each integer is in the range given by the closed interval 1 and n inclusive. So this is actually very special. The reason is that if the length of this list is n+1, then their elements is starting from 1 and up to n, right? So here it assumes there is only one repeated number in nums. So we want to find this repeated number. So also we want to solve the problem without modifying the array nums and uses only constant extra time. So I guess here this sentence or paragraph is the main point for this problem. So I'm going to first give one solution based on set to digest how we can find duplicate numbers. And then we are going to explain another one using index as indicator, but we need to modify the array. And lastly, we want to reveal or regard this problem as a linked list problem. So, and then we use a circle detection algorithm to find the repeated element. So here are two examples. So they are very easy to interpret. In the first example, the repeated element is 2. And in the second one, 3, right? So here the constraints are the following. First, n can be as large as 10 to the power 5. And the length of this nums is n+1. And the element is in between 1 and the length minus 1, right? All the integers in nums appear only once except for precisely one integer, which appears 2 or more times. So with that said, let's look at the problem analysis. So first, I'm going to specify the strategies. The first strategy, I'm going to use a set. So this is nothing but using data structure to solve the problem. So this is very simple, right? So we can use a set called sin, right? Then we just need to do a traversal. So for the number in nums, then we want to check if y in sin, right? If it's in the set, it means y appears already. So this must be the repeated element. So we're going to return. Otherwise, so we're going to add this current element to the set. So by the problem assumption, there must be a repeated element. So this actually completes the coding part. Let's first do a test. So it accepts for one special case. Now let's look at the generic case. Yeah, it passes the test. But here the thing is that in this one, we are using set abstract data type. However, so this is not constant time. So here it can be an O of n in space. So let's see, space can be O of n, and is the length of this nums, right? So also, so this time complexity, if we just consider that, it's O of n because we did a traversal or scan. So this is for solution V1. So I guess this is helpful for us to digest the problem. So next, I want to give another solution. So in the second solution, so we do not use extra space, but we modify the nums element. So for this, what I'm going to do, I'm going to using index as indicator, right? The main reason is that, so if the length of the nums is n+1, right? It means that the indices running from 0 up to n, right, inclusive. And this element is also in this range. So this is the this is the key point, so that we can use index as indicator. So we are going to modify the element in the corresponding index as negative, meaning that we have already seen that element. So let's do it like this. I'm going to use n, right, as the length, right? So I'm going to do a traversal. So for I in range m. So the atom here, I'm going to use absolute value because some I'm going to modify, right? So here, let's check if nums at the current index. So this atom actually also interpreted as index. If this index is less than 0, it means that this atom appeared before. So we are going to return atom. Otherwise, so what we want to do? We want to do, so for atom, so I'm going to flip its sign, right? So due to the problem assumption, so this will give us the repeated elements. Let's do a test. Yeah, it passes one case. Now let's look at the generic case. Yeah, it passes all the case. So here, let's give you a walkthrough for example 1. So here, walkthrough for example 1. So here we have, this is the nums, right? So if we, at index 0, so we are looking at atom, it's 1, right? So negative 1 does not appear. So we are going to flip nums. So we are going to change this nums to the first, at index 1, we are going to change it to negative. So negative 3, 4, 2, 2. And then next time at index 1, we are going to look at the atom. So here atom is negative 3, but we use absolute value, so it's 3. Index 3 is a 2, it's not negative, so we flip that. So negative 3, 4, negative 2, and 2. And then at index 2, we are looking at index atom 4, right? So at index 4, it's still positive, right? So let's flip its sign. It's going to be 1, negative 3, 4, negative 2, negative 2. And then look at index 3. So we are going to have, at index 3, so we have negative 2, so we consider 2. At index 2, so the element is 4, it's still positive, so we flip it. So it's negative 3, negative 4, negative 2, negative 2. So now let's look at index 4. So we have atom equals negative 2, so we use absolute value, that is 2. Then at index 2, so we have something negative, right? It's because numbers at atom is less than 0. The specific value does not matter because we just focus on the sign. Then we return it. So return atom 2. That is the merit for this problem. So or for this coding. So this is the second solution. But here what we did, so we do a scan. So the time complexity will be O of m. And but we modified the nums array or list, right? So this is not in full conformant for this fulfillment for this assumption or requirement. So now with this done, I guess we have a very good understanding about this problem. Let's look at another solution. So in this solution, we are going to do this, but without modifying the code. So here, actually, what I want to do is nothing but the very standard slow, fast pointers. So in this case, so you can think of linked list. So, and also you can think of the find method in union find or disjoint set. So we have a YouTube playlist which contains quite a number of union find problems. So we implement the find method. You can have a look there. So what's the thought here? So here, duplicative elements corresponding to cycles yields cycles. The reason is this. So you can regard, so here at this 3. So then because it's at no, we look at index at 3, and then this is the 4. I mean, look at index 4. So in other words, if we regard nums this as a function, right? So originally we have an element, so that is say num 0, that is 3. Let's use example 2 as example. Then we apply this function, right? Apply this function to get the next element. In other words, that's nums 3. So nums 3 is at index 3, the 0, 1, 2, 3. That's the 4, right? And then we look at we apply the function to 4, right? So that is nums and 4. So this is 2, right? And then we apply the function to 2, right? This is the f applied to 2. At index 2, that is 3, right? So that is 3. 3 has appeared. So this is the duplicate elements. So the thing is, how do we detect the cycle, right? So it's the Floyd method, right? Then if it detects the cycle, so we can also detect or find the entrance point of the cycle, right? So this is actually very very standard. So now let's regard this as a linked list. So the pointers you can regard as 3 points to F3, and then F3 is 4, and then apply to F again. So this will be the chain, right, or link. So now let's use fast slow pointer to get first find the place the fast and slow meet. Find place where slow and fast meet. So for this, I'm going to define slow and fast. So starting from the very beginning, right? And then, well, true. So what we want to do? So we want to slow move forward 1 step. That is, we apply this nums once. And the fast, right? You can apply this, extend this nums as the f, right? This corresponding to slow equals slow next in linked list, right? So let's use this comment. Then fast will be nums fast, right? So this corresponds to fast equals fast next next. Of course, the condition should be that fast next is not now, right? So once we get this, and then later, so if slow and fast meet, right, then we just break. So when we break, actually we get a fast and slow state where they first meet. And then we can start from the point they meet, and then we can start from the very beginning. So let's say start equals nums 0. And then we compare start and the place fast and slow meet. So they move forward, and then they will meet at the entry point. So, well, start does not equal to, you can use slow or faster. Let's use slow, but for now, you just move 1 step each. So start will be start next, or you can see it's nums start. And the slow will be nums slow. So let's make a comparison, right? So this corresponds to start. Let's say use slow or start. Start equals start next, right? And this corresponds to slow equals slow next, right? So after we act this while loop, so start and slow will meet. So this position will be the position for the circle entrance point. So we are going to return slow or start as you like. Let's return slow. So if you have difficulty in understanding the logic here, I would suggest that you draw a circle or draw a figure to help digest. So with that said, I guess we are ready to do some test, right? So yeah, it passes one case. Now let's look at the generic case. Yeah, it passes all the cases. So I would say for this specific problem, because the statement or the design of the problem is very special. So we have quite a lot of methods can be used to solve this problem. So here we give three strategies. One is using set, and another is using index as indicator, right? And the third one is using slow fast pointer. So here the extension would be that. So you can think of the find method in union find method, and you compare. So actually it's almost identical. In other words, we form a chain, right? If we see some previous element in the chain, then it's the duplicate elements, right? It always corresponding to we find the root or ancestor of a node. So this is one. And another one is that you can think of linked list, right? Linked list. So the problem will be detection of cycles and find entry points of the cycle. So these kind of problems are actually good to try. So with that said, I guess that's about it for this specific video. Thank you.